In this video, we're going to look at sigma notation for series representation. So the first example we're going to take a look at is to evaluate the following series. So we're looking at the sum for n equals 3 up to 7 of n squared minus 3. So we just take a look at summing. The sigma notation we've got is, so we're looking at the sum using sigma notation n equals 3 up to 7, and the series we're interested in is n squared minus 3. So we simply sub in, starting at 3, so the first term will be 3 squared minus 3, and to that we'll be adding the second term, 4 squared minus 3, and to that we're adding the next term, 5 squared minus 3, and the next term, 6 squared minus 3, and the final term will stop when n equals 7, is 7 squared minus 3, plus 7 squared minus 3. So what have we got here? We've 9 minus 3, we've 6 plus 16 minus 3 is 13, plus 25 minus 3 plus 33, plus 49 minus 3 is 46, and we can just quickly pull up the calculator to do that. So we have 6 plus 13 plus 22 plus 33 plus 46 equals 120. So that's the final answer on evaluating the series that we were given using sigma notation. The next example we'll look at, again, just another summing exercise, and this time we want to find the value of the series, which is given by the sum from n equals 3 up to n equals 6 of 2n squared minus 3n. So we take a look at that one. We'll just note the sigma notation first, and we are looking at, we've got our sigma here. We had n equals 3, and we'll be stopping at n equals 6, and the series is given by n squared minus 3n, or 2n squared minus 3n. So again, we'll sub in n equals 3 first, so we've got 2 times 3 squared minus 3 times 3 plus 2 times 4 squared minus 3 times 4 plus 2 times 5 squared minus 3 times 5, and then we'll stop when n equals 6, the last term, plus 2 times 6 squared minus 3 times 6. And we can calculate that, and the first term is 18 minus 9 is 9. The second term, 2 times 16 is 32 minus 12. Second term gives us 20. And the third term is going to give us 45. 2 times 25 is 15, minus 15 is 35, not 45. And the last term, so we've 6 squared is 36, 2 times 36 is 72, minus 18 is 54. So that will finally give us 9 plus 20 plus 35 plus 54 is 118. Okay, so that's the answer for the second example. 118 is the sum of that series. The last example we want to look at, again, we're going to just evaluate. This time we have the sum of the series from n equals 4 up to n equals 8, 5 times 2 to the power of n. And write it down here. N equals 4 up to 8, 5 times 2 to the power of n. So the first term in our sequence is 5 times 2 to the power of 4 plus 5 times 2 to the power of 5 plus 5 times 2 to the power of 6 plus 5 times 2 to the power of 7. And the last term is 5 times 2 to the power of 8. Now what I can do, maybe just open the calculator and do it all in one go on the calculator. So I'm going to take the 5 outside. I'll factor the 5 out. That way we'll just have 2 to the power of 4. So we have 2 to the power of 4 plus 2 to the power of 5 plus 2 to the power of 6 plus 2 to the power of 7. That's what I'm doing there. 7 plus the last term being 2 to the power of 8. And I'll close my brackets and calculate. We have a syntax error there, so what have we done? We forgot to put the plus in there, and just double check I've got my brackets, and the answer to that is 2,480. So that's the final answer of the third example, 2,480. So that's all for this video. Thank you for watching.